Thanks for tuning in. In this short video, I just want to provide a little brief overview of how cities can reduce the embodied carbon in the concrete that is used in the city. Embodied carbon is basically just a term that we use that reflects all of the emissions that were created in the making of the materials that went into concrete. And increasingly, a lot of different states and municipalities are looking to concrete as a way to reduce the emissions within their cities. Specifically, you might be based in a municipality in California, which has Cal Green, which is a first of kind program in the country, which is part of that. It's related to the building codes. It requires a certain amount of embodied carbon reduction in the building code in concrete. There's both a compulsory version of that and then a more stringent voluntary version of it. So this is a good resource for people who are exploring that. And then alternatively, other cities and states also are developing similar types of approaches, like in Colorado, for instance. But then there's also the American Concrete Institute recently in November 2024 introduced a new code amendment called ACI Code 323, which is meant to be added to building codes, and it's very similar. It requires a 15% reduction in embodied carbon in the building code, in city building codes or state building codes. And so this is hopefully a useful resource for people that are beginning to wrap their heads around that or explore. These types of programs, both the Cal Green, the ACI code, and some other similar ones around the country at both the municipal and state level, they're typically, they aim for a 10 to 20% reduction in what's called GWP, and that's global warming potential. That's just another term that basically is synonymous with embodied carbon, a measurement of that. And usually that 10 to 20% is relative to some threshold that the state generated or maybe a city, but it can also be relative to the sort of regional average that the concrete industry, the ready-mix industry itself produces. There's 8 regions. So that's what we're talking about, a 10 to 20% reduction relative to some threshold. Now, the big question that many people ask is, well, what do we even talk about low carbon concrete? Is that some sort of special concrete that comes from a special concrete batch plant? And the answer is no. Low carbon concrete is a general or generic term that just means any kind of concrete that is below that threshold or at that threshold, if that threshold already represents a reduction relative to the average. And there's many different ways of achieving it. And importantly, not at some special factory, but rather at your local batch plant or your local block maker can lower the carbon of their concrete through many different ways. And that's what I'd like to cover at a pretty high level right now. And I think the best way to do that is to look at the material itself, concrete. A typical kind of ready mix that's, in our foundations, our roads, sidewalks, consists of a few elements that are combined. Most of it by mass is what we call aggregate. And that's basically just sand and gravel mixed together. Then the all-important ingredient of cement, or Portland cement, to be most commonly. And that's the really, really important binding agent that actually turns a bunch of materials into what we know as concrete, that hardens and is durable and persists for a long time. Water is added to make that process happen. And then a variety of other trace elements, which we usually call admixtures, that have different types of effects, like accelerating hardening rates, and they do different things. So that's what concrete, if you look at it, think of it like a cake, those are the ingredients. But when you think of the embodied carbon or the emissions that are associated with concrete, almost all of it, typically just rule of thumb, 90%, sometimes it's less, sometimes it's more, depending on how much cement is in there. But cement is the most carbon intensive element of concrete and is responsible for the vast amount of emissions that are associated with concrete. And so when we think about achieving lower embodied carbon in concrete, obviously then most of that is associated with addressing those cement-linked emissions. And there's a couple of different ways of doing that. But in addition to that, in addition to directly changing the status or the quantity or the nature of cement, some of the other materials that can be added to the concrete, and this is becoming increasingly more varied and diverse with new products coming on the market, those can actually balance some of the emissions from the cement because they have superior, sometimes negative carbon, embodied carbon. So you can add that and it balances the cement emissions. And so the first thing to focus on then has to do with cement, as I mentioned. And there's ways of reducing cement. That can mean just not over specifying, not using more cement than you need to do the job. If you want a certain strength or hardness, we often actually add more cement than is required. So being able to trim off at the margins the amount of cement you use to get the same result is one way of doing that. And another way of doing it, and there's also other materials what are called supplemental cementitious materials or SCMs that can be added in lieu of Portland cement, some portion of it, 5, 10, 15%, and they have lower embodied carbon, so that reduces the embodied carbon of the concrete. Now, other options that are emerging right now, which are quite exciting in the next, few years, we're going to start seeing them more common in the marketplace, are wholesale replacements for Portland cement, using other kinds of cement that have a much, much lower embodied carbon compared to Portland cement that do the same thing. And so those are two options when we think about addressing the emissions that are associated directly with cement. Now, some of those other types of interventions that can be added that have more of a balancing effect are things like utilizing carbon, whether in gaseous form or in mineral form, can be mixed into concrete mixes, sometimes displacing cement, sometimes making cement harder. But one thing they do is they lock away carbon that, whether it was from a smokestack or pulled right out of the air, that is driving climate change, we can actually store that and lock it away forever in concrete, which is really, really exciting. And there's many options that are really coming to market right now related to that. And then other methods are taking some waste materials, some industrial waste materials that might be present in your city, as well as waste concrete, which is the largest part of our waste stream in cities. That can actually be broken up and used as aggregate. And there's other fancier things that you can do with that can be added to concrete that reduce its overall embodied carbon. Now, these things often overlap in certain ways. These are not pure separate categories. Like, for instance, you might have a form of SCM that is made out of carbon in mineral form, like a calcium carbonate. So that's both carbon utilization and a cement reduction. So these things overlap quite a bit. But the important thing is there's many different categories of them, which we call methods or materials. I'm not going to go into them in any depth, but I just want to illustrate that there are options that can be pursued at the local city level to reach that 10 or 20% reduction or whatever you're trying to reach in terms of lowering the embodied carbon locally in the concrete you use. One of the key ones, though, which is kind of a gateway to the others, which is very important, is becoming increasingly more common both at state and municipal levels, is what we call performance-based specification, or PBS. And this is actually a move that is supported by the concrete industry itself. And what this is, it's an alternative to the way that concrete is normally specified. So that means when somebody wants to build a building, the engineers would conventionally prescribe exactly what materials they're supposed to use and what proportions. And the problem with that is that it makes it very difficult to add new things or innovative things that might perform better or have a lower cost or reduce the embodied carbon. The alternative to that is called, as I said, performance-based specification. And this is, rather than focusing or requiring specific ingredients in specific proportion, like this amount of cement, this amount of aggregate, these admixtures. Instead, it starts with, well, what do we want the concrete to do or be like? How strong do we want it to be? How workable? How durable? And you set parameters for that, and then the builder is able to pick a variety of materials that meet that criteria. So that's performance-based, and that's important because it opens up the options to adopt some of the things that I'm about to describe. Now, I'm not going to go into these in any depth. This is, again, those materials and pathway categories that I showed just a minute ago. What I want to show, though, is there's a lot of them. This is only just a partial list, and they're growing all of the time. And the ones that I have highlighted blue are what we call breakthrough materials. These are types of materials or alternatives that have really, really deep decarbonization, much frequently above 10 to 20% reductions in embodied carbon, sometimes 50%, 75%. And those are going to become increasingly common as the years go by, with more and more alternatives coming to the market. So there's many options, and importantly, they can be combined. You don't just pick one of them. You can combine different combinations of these materials that can get you to the goal that you want to. And importantly, not in some special factory for concrete, but your local batch plants or block producers can actually implement these as well, which is important. And as I said, what's really cool about it is that they can be stacked or they can be combined in different ways depending on what you're trying to achieve, what your cost parameters are, and what's available to you locally. So just to give an example, a real spectrum here. On the far left there, you could get a little bit of cement reduction and then add a very common form of cement called 1L or Portland limestone cement that's being produced at normal cement production facilities all over the country now. And this is about 10% lower global warming potential compared to normal Portland cement. So if you added those two together, you would be able to reach, what your local goal is, per the ACI code or Cal Green or things of a similar nature. As you go further to the right, you can see that more different types of things can be added together as different kinds of aggregates or different kinds of like a super plasticizer, which reduces the amount of cement you have to use. You might use a calcium carbonate mineralized substitute for cement. These are just examples I'm putting down. And then on the far right, some of the really emerging technologies that we'll expect to see available more commonly where in cities all over the country are forms of cement like electrochemical cement, which has zero emissions associated with it, but performs in the same way as conventional cement. And then if you use something like biochar, which stores carbon in it, and can be used as aggregate, which is most of the mass. So if you were to combine those types of things together, you would have not only a net zero emissions concrete, but potentially even a carbon negative concrete. So I show these things to you because there are options that are available today that make the prospect of having to comply with a code that requires embodied carbon reductions much more doable. And there's many more options that are coming online right now that allow us to vastly exceed those reductions. So hopefully this was helpful. Just wanted to give you a basic overview, and good luck with your pursuit in reducing embodied carbon in your city.